Hey, what's up, guys? Hey, today I want to issue a challenge. All right, we're going through Unit 9, and I've caught wind that multiple classes are watching my YouTube videos. So, with that being said, I want to issue a challenge for whatever student, all right, or students score a perfect on Unit 9 test, meaning a 100, all right, or higher. Bring me your test, all right, and I will reward you for that, all right. But you have to be a student that looked at my videos, all right. So you got to tell me, Coach, I looked at your videos, they helped, all right, and I scored a perfect score or better, all right, because I believe there are some bonus questions where you can get higher. Okay, so not near perfect, but perfect, 100% or better. Come see me, all right, and I'll make sure I have something for you. All right. Hey, I appreciate y'all watching the videos. Make sure you subscribe, all right, to my channel. I'm going to make them public so you don't have to go to eClass anymore to look at them. You'll get a notification when I put it up. And if you like the video, all right, if you take a video, you look at it, you like it, man, just hit the like button for me. I appreciate it. Now, let's get into some math. All right, we're back, guys. Hey, this is 9-3 video absolute value. All right, a couple essential questions here. How do we graph an absolute value function? All right, a couple key terms are absolute value functions. All right, the vertex of an absolute value function and the axis of symmetry. All right, the axis of symmetry. So let's dig right in. Absolute value function, guys. The graph of f of x equals absolute value. This right here, guys, means absolute value when you see a function. All right, and it has this deal going on right here with the two lines here. All right, the two lines, the vertical lines outside of the function. That means absolute value. All right, so sorry about that. The first thing we're going to do is, well, let's see, all absolute graphs are V-shaped. All right, don't forget that. Every last one of them, guys, is a V-shape. All right, V-shape. So when you see a graph that has a V-shape, it is an absolute value. All right, the vertex, all right, slope or steepness, and direction they point in. All right. The general form of an absolute value, guys, function is like so. All right, you got plus or minus a. All right, times the absolute value. All right, now the thing I want to talk about is this. All right, if it's negative, all right, make sure you know that that reflects over the x-axis. All right, which means it's going to be facing down. All right, and then horizontal shift left and right. We did this. All right, we did this before. But make sure you do the opposite of the sign. If it's plus here, then you're going to move to the left. All right. If it's negative, you're going to move to the right. All right. So do the opposite of what you see. And then, of course, K is your vertical shift, up or down. All right. Up or down. Okay. Also talking about A right here. All right. If A is greater than 1, is a stretch, vertical stretch. If it's less than 1, meaning a fraction. Or decimal, but not just any fraction. If the fraction has a smaller numerator than denominator, all right, then it's going to be a compression. Like let's say a was 1/2, or something like 1/2, or 3/4. All right, that's not a whole fraction, so that's going to be less than 1. All right, therefore it's a vertical shrink. All right, vertical shrink. All right, so gotta practice these problems, guys, in order to get better at them. Okay. Let's go ahead and look at this first example right here. I'm gonna get rid of this so you guys can see the whole screen as I write. All right. But in this first example here, it says write an equation for the following graph. All right, and identify the intercepts, the zeros, the intervals of increase and decrease, and compare the graph with the given or excuse me, with this function, y equals the absolute value of x, okay? So the first thing I'm going to do is make an equation based off this graph. All right, so the first thing I want to point out to you guys, we're going to look at this point. All right, the vertex, that's the vertex, okay? We need to come up with our a value. All right, we're going to come up with our a value. And our a value, or our vertex, is also called our slope. All right, that's our slope, okay? A and slope are the same thing. All right, and what we do is, let's pick 2 points we can actually see. I can see this point right here, and I can see this point right here. All right, now, if you guys remember, man, you learned this with dealing with slope, but slope is called, or you can say it's the rise over the run. All right, the rise over the run, which means up or down. All right, up or down for the rise, and the run means left or right, okay? Left or right. So I'm taking my time explaining this, guys, so you get it. All right, but the thing is, all right, for the rise, starting at the vertex, all right, to get to this point, how far up do I need to go to get on that same line, all right, to where this point is? Well, I went up 1. All right, so in this case, the rise is 1. All right, from this point to this line where this point is, all right, this point here is, I went up 1. All right, and now my run is how far over left or right do I need to go to get to this point? Well, I went over twice, 1, 2. All right, or you can go up 1 and then go 1, 2. All right, either way it goes, still 1, 2 with a rise of 1. All right, so the run is 2, the rise is 1. So the rise is 1, the run is 2. That gives us a slope of 1/2. So A, guys, is 1/2. All right. Now, the next thing I want you to do is go to the center right here. All right, this is 0.00. All right, let me use another color. 0.00. All right, and I want you to notice something. Look at the vertex. How far left is this vertex right here? All right, it's 1, 2. All right, 1, 2. It went left 2. The vertex. We're not looking at how far down right now. We're just looking at how far left this is, okay? All right, so that tells me that the interior portion of this, all right, remember the h value? All right, let's look back up here. The h means how far left or right. All right, horizontal shift left or right. But you got to do the opposite. Since this went left, all right, from this 0, 0, all right, the origin, it went left 2. So we say x plus 2 because we got to do the opposite. You do the opposite of this sign, which means since it's a plus, from the origin, we will go left 2. All right, so the slope is 1/2. All right, and here I don't want to put this together. I'm going to take the pieces and separate them apart. All right, the slope is 1/2. All right, now as far as the middle part, all right, so I'm making the equation. The middle part here, you have x plus 2. All right, and then let's look how far down the vertex is from the origin. All right, the vertex. All right, remember k. All right, K tells us up or down, all right, how far up or down this thing moved, okay? So, all right, from the origin, this point, the vertex is 1, 2, 3 units down. All right, 3 units down. So K is -3. All right, and by the way, this is H. H is 2. All right, H is 2. So when we make an equation out of that, we put all that together, your equation is this. Y, or f of x, equals 1/2. Remember, A goes first. All right, absolute value, x plus h, because remember we went to the left 2. All right, and then we went down 3, so -3. All right, only thing that's opposite is what's in the absolute value. That tells us left 2. This means down 3. K is exactly as it is. All right, if it's negative, go down. If it's positive, go up. It's -3 because we went down 3. Okay, so that's our equation. Okay, now the intercepts. We can find the intercepts. All right, a couple different ways we can do it. All right, for the x-intercept, here, let me make this bigger so I can have space to write. Intercepts for the x-intercept. One thing I want y'all to remember for the x-intercept is that your point, your coordinate point, well, first let's back up. You guys remember your coordinate point is always in such X and Y. All right, it's always a coordinate point like this. All right, X, how far left or right, Y, how far up or down. Okay. All right, here, let me add a screen. I want to show you guys something, man. I want you to always remember this. All right, always remember this for your x-intercept. For your x-intercept, you always got to find your x, okay? But what we know 100% of the time, fact, all right, that will never change, is your y value is 0, all right? And your x-intercept, your y value is always 0, okay? For your y-intercept, all right, this is fact. One thing we know will never change, all right, is we got to find our y value, all right? Your x value is always 0. All right, these two things right here will never change. X-intercept, your y is always 0. Y-intercept, your x is always 0. And the reason being is because, think about it. On your x-intercept is some point that lies on the x-axis, right? And it doesn't go up or down any. All right, it's on the x-axis, which means hypothetically, let's say this was 1, all right, 1, 2. This was 2 right here. Well, that point would be 2, 0. All right, it's 0 because I didn't go up, I didn't go down. I'm on that axis. All right, on the latter side, all right, let's say this was -2. That would be -2, 0. I didn't go up any, I didn't go down. It's on the x-axis, okay? Over here, take a look at this graph. All right. The y-axis, or the y-intercept lies on the y-axis. All right. So let's say hypothetically this point was y is 2, right? So your x would be 0, 2. All right, because remember the origin, I didn't go left or right. I just went up 2. So I didn't change the x, 2 went up. All right, so that's up 2. Well, let's say this was hypothetically -3 right here. All right, that y-intercept would be 0, -3. I didn't go up. I didn't go left or right. I just went down 3. All right. So make sure you know these rules right here. All right. That'll make solving for the x and y intercept very, very simple. All right. Very, very, very simple. Okay. So with that being said, I'm going to write our equation down again. We said y equals, well, the equation was actually f of x equals 1/2 times the absolute value of x plus 2 minus 3. All right. So I'm going to find the x-intercept first. All right. Using this equation. Okay. Remember, for the x-intercept, I just said that, think about it. What is always 0? All right. The y value is. The y value is always 0. Okay. So if I do that and apply that, well, we can rewrite this equation as f of x. Instead of f of x, we can rewrite it as y equals 1/2 absolute value x plus 2 minus 3. Okay. Now that we know that we can rewrite f of x as y, I can actually solve for my x-intercept by making my y value 0. So if I set it up like this, y equals, or instead of y, I put 0 there. I substitute 0 in place of y. 0 equals 1/2 x plus 2 minus 3. And then I just solve for that x, okay? Solve for that x. So now, what would be my first step? Well, my first step, we're going to add 3 on both sides, okay? Add 3 on both sides. All right. So once I add 3, hold on, let me change the thickness of this pen. Once I add 3, all right, 0 plus 3 is 3. Now 3 equals 1/2 the absolute value of x plus 2. Now, how do I solve it from here? Well, we're going to divide, or better yet, let's go ahead and get rid of 1/2. And how do you move the 1/2 to the other side? Let's just multiply by 2 on both sides. All right, multiply by 2 on both sides. We're not looking at that anymore. That was the first step. All right, so multiply by 2 on both sides. And that 2 would cancel. All right, so we have 2 on this side now, and that's 2 times 3, which is 6. So 6 equals x, absolute value of x plus 2. All right. And now all we have to do is solve it from here. All right, solve it from here. And when we do that, now guys, once you get here, a very critical thing has to happen. Absolute value, guys. Remember how the absolute value represents both a positive and a negative? Like, for example, if you had the absolute value of -6, you would say it's equal to 6. So there's a negative element here and a positive element. You have to apply that same logic to solving the absolute value here, guys. All right. So here's the absolute value. Once you get to this point, take a second. You got to set up two different equations. You need to have a -6, a negative element, and you also need to have a positive element. All right. Get rid of the absolute value. You need a negative element and a positive element to kind of reflect what we did here. The absolute value of -6 is 6, right? The absolute value of 6 is still 6. All right. There's a negative element and a positive element. All right. So here, now you solve the equation. I'm going to go -2. All right. -6 minus 2 is going to be -8. All right. And right here, -2 again. 6 minus 2 is 6 minus 2 is 4. My apologies, that's 4. All right. So these right here will serve as our x-intercepts. All right. Remember, y is 0. So our first x-intercept is -8, 0. And our other x-intercept is 4, 0. All right. These are our x-intercepts, okay? So let's go back to our worksheet and put our x-intercept values. We said -8, 0. And we also have the comma, guys. We also have 4, 0. Okay? Now, the next thing I want to talk about is the y-intercept, okay? Let's do that in another color, y-intercept. All right, I'm going to go back to our other slide. Remember our y-intercept, people? Your x value is 0. So I take my equation. All right, here's the equation. And I make x 0. Oh, I'm sorry, did I say that wrong? The y-intercept, the x value is 0. All right, the x value is 0. So we're going to go back to our equation. And we're going to set our x equal to 0. So you have 1/2 of 0 plus 2 minus 3. And then we just solve this, okay? Right here, 0 plus 2 is 2. All right. Well, the absolute value of 2 is 2. So you have 1/2 times 2. All right, minus 3. And then right here, 1/2 times 2, guys. Well, half of 2 is 1. Or you could cancel the 2's and just have 1 times, or just 1. All right, so y equals 1 minus 3. And then 1 minus 3 is going to give you -2. So your y-intercept is -2, and your point will look like this, 0, -2. This is your y-intercept, okay? So let's add that to our table. 0, -2, okay? So there's your x-intercept and your y-intercept. All right, now for your zeros, guys, your zeros is always the same as the x-intercept. All right, so what, of course, is your zeros? Well, here I'm going to erase this just so we can have space. Your x-intercept is going to be your zeros, which were, or your zeros, excuse me, are your x-intercepts. So we had -8, 0, and 4, 0. All right, those are our x-intercepts, okay? Now, increasing and decreasing. Increasing and decreasing, let me go back to our graph. All right, and some sketching for you because I want to try to take a second to explain this for you, okay? Out here to the left, guys, all right, there's a value that exists, all right, infinitely that way to the left. All right, we're going to refer to that as negative infinity. All right, now right here at the vertex, all right, where's this vertex? 1, 2, that's negative 2. All right, that's the vertex. And out here, way to the right, because the arrow continues, is positive infinity. All right, we got to describe the graph, okay? But you got to read the graph from left to right. All right, from left to right is how you read this graph, okay? And the thing I want to point out is from left to right as I approach the vertex. All right, look at this line. All right, and remember, it continues that way, but we're going to trace the line back to the vertex. If I trace this line back to the vertex, right? All right, this is just me extending the line. If I trace the line back to the vertex, we're going to say that that's a decrease. All right, it's going down. All right, if I were to walk along this line to the vertex, I'm going down. All right, and if I leave the vertex and go in this direction and follow the line, that's an increase. I would be walking up a hill, right? Down a hill, up a hill, all right, or increase, all right, increase. Now, I got to scale that. How we scale that is in terms of the x values, all right? And how I teach my students are write down what you know. We know that way out here is negative infinity. We know that the vertex is right here at negative 2, and we know that way out here is to the right is positive infinity. Okay, so now we can actually describe this graph. All right, we can say that right here, between this point right here is our decrease. All right, because we're going down, and between this point right here is our increase. And then we just translate that, all right, into notation, all right, on our paper here. So for increase, all right, what is the increase? From negative 2 to positive infinity. All right, as long as you can set it up here and understand, all right, your line as you approach the vertex from left to right, you'll be fine. All right. So again, from negative infinity way out here, I'm walking along this line, I'm going down to the vertex. So that would be a decrease. All right, so for my decrease, we say from negative infinity, all right, to negative 2 is going to be our decrease. All right, and then from negative 2 to positive infinity is our increase. All right, there's your increase and then decreasing, okay? The last thing we want to do is describe the transformation. Well, let's start at the origin. All right, I'm going to clear this off again. Let's start at the origin, okay? Starting at the origin, we have, all right, here's the origin, 0, 0. 0, 0. All right, and then we just describe the transformation, and you use the vertex, okay? Use the vertex to describe that. All right, and here's how you say it. All right, from the vertex, all right, let's move along the x-axis. We want left 2. So for our transformation, we write left 2. All right, and then from this point, 1, 2, 3, we went down 3. And that's your transformation, guys, okay? So please use that. I hope this helps. All right. So now let's look at the next problem, okay? Our next problem right here, we have a upside down V. All right, upside down V. So we're going to make our equation based off this upside down V. All right. The first thing I want to talk about is, since this is upside down, that means it reflected over the y-axis. All right, it reflected over the y-axis. So we know that our equation, f of x, will have a negative out front. All right, the negative goes out front immediately because this is upside down. All right. The next thing I want to talk about is, let's find our a value, all right, or our slope. All right, remember a. Our a is our slope. All right, it's the same thing, okay? But to find the slope, we use the term rise over run. All right, rise over run. And how do we do that? We start at a point that we can see. Here's a point that we can see. And you find another point that you can see, which is right here, okay? So now we'll come from this point and work up, all right? Or you could work down. It doesn't matter. It's the same thing. Just remember, rise is up and down. So I'm going to work down this time just to give you a little difference. So since we're going to work down this time, all right, what I want you to do is count from this point for our rise. Now, how far down we go. So we went down 1, 2, 3, 4. All right, we went down 4 lines before we hit this one, 4 lines. So the rise is going to be -4. All right, and then we will go, how far to the right are we going right here? So 1, 2. So 4/2, right? -4/2. All right, so now looking at this, we can actually simplify that. All right, for our rise is -4. All right, went down 4, went right 2. We can simplify that. -4/2 is going to give us -2. All right, so our slope, guys, A equals -2, okay? So let's have a look at that. Was actually 2. All right, we're going to say 2. All right, we're not going to say -2 because A, guys, A can only be greater than 1 or between 0 and 1. All right, matter of fact, here, let me go back so I can show you. Right here, all right? Yes, there's a plus and minus right here, all right? And that has no bearing on A. A can only be, all right, greater than 1 or between 0 and 1, which means it can't be negative. All right, think about it. If you got 0 on the number line, you got -1, 0, and 1. All right, and A is between 0 and 1. Well, that's positive. Everything past 0 is positive. All right, everything this way is negative. So everything right here is positive. So we're going to say 2, okay? It's going to be 2. Now, don't forget, we still have that negative. Oops, sorry. We still have that negative out front. All right, so let me go to that. All right, the negative is still out front because it flips upside down. And then A is going to be actually 2. All right. Another way to look at it would be if I started from this point. All right, I went right 2, which would be the run, up 4. So I'd actually have a positive, all right, positive slope right here. That'd be 4/2. All right, right 4, up, right 2, up 4, 4/2, which is 2. All right, so there we go right there. That's our slope, 4/2. All right. And then 4/2 reduces to 2. So you have right here 2. A is 2. Now, we got to figure out what our absolute value is, okay? And that, guys, remember you start right here at 0, 0. Let me erase this so you can see. All right. We started at the point 0, 0. All right. So from 0, 0, we go over 1, 2. All right, we're looking at where the vertex is. All right, where the vertex is. All right, the vertex goes over 1, 2. It went 2 right. So 2 right means you do the opposite, x minus 2. All right, x minus 2. H is -2 to make you go right 2. All right, and then we got to evaluate the k value. All right, the k value out here, since this is up, all right, it's going to be up 3. So 1, 2, and then up 1, 2, 3. All right, so you have +3 right here. That's our equation, guys, that represent this line. All right, that's our equation, negative. All right, or you can say y equals -2 times x minus 2 plus 3. All right, the absolute value of x minus 2 plus 3. Okay, there's our equation. All right, next for the intercepts. All right, I'm going to go back here for our intercepts again. Okay, and remember our rule. All right, where for the x-intercept y is 0, for the y-intercept x is 0, and if I take our equation, oops, sorry about that. All right, but anyway, if we take our equation, y equals -2 x minus 2 plus 3. And let's do the x-intercept first. So for the x-intercept, we're going to make we'll make y 0. All right. The first thing we're going to do here is, you guessed it, subtract 3 on both sides. All right, so 0 minus 3 is negative 3. All right, equals negative 2 times the absolute value of x minus 2. All right. So now we need to divide this 2 over here, right? So it's multiplied by 2. So we're going to divide by negative 2. All right, divide by negative 2. So if I divide this whole side by negative 2, all this cancels. All right, so you have negative 3 over negative 2 equals the absolute value of x minus 2. Now, the thing I want to point out is, first of all, that becomes positive because of the 2 negatives, they cancel. All right, so now this is now positive number 3 over 2. All right, again, they both are negative, so here's what we got. Now, remember I told you guys you must have a positive element and a negative element. So let's look at that. We have the positive element and the negative element. So you have 3 over 2 equals x minus 2, and you have 3 over 2 equals x minus 2. Excuse me, negative 3 over 2 x minus 2, right? All right, for the x-intercept. So now we got to go 3 over 2 plus 2 on both sides, right? So if you don't remember, 2 is the same thing as 4 over 2, right? Right, so 4 over 2, because 4 divided by 2 is 2. All right, so common denominators, however you want to look at it. So 4 plus 3 is 7. So you have 7 over 2 equals x. Over here, add 2. All right, so we add 2. Again, we can convert 2 to 4 over 2 minus 3 over 2. All right, and 4 minus 3 is 1/2 equals x. So we have 1/2. All right, and we have 7 over 2 are our x-intercepts. So again, when you write them out, you have 7/2 comma 0, and you have 1/2 comma 0. All right, those are the x-intercepts. All right. Now we got to find our y-intercept. All right, got to find our y-intercept. So for the y-intercept, let me go back, take our same equation. Let me clear this out, give us a little space. All right, for our y-intercept, we need to take the x value. All right, review. The y-intercept of the x value is 0. All right, so with our equation here, we make x 0. So we have y equals negative 2, 0 minus 2, absolute value 0 minus 2 plus 3. All right, where you get y equals negative 2. 0 minus 2 is negative 2, guys. All right, now what's the absolute value of negative 2? All right, well, y equals negative 2 times positive 2. The absolute value of negative 2, guys, is positive 2. All right, so negative 2 times 2 is negative 4. Oops, plus 3, right? And then negative 3 plus, 4. Negative 4 plus 3 is going to be negative 1. All right. So our y-intercept is going to be 0, negative 1. All right. So we go ahead and add that to our worksheet as well. And this will be our y-intercept. Okay. Now we have what's called the zeros. All right, the zeros. All right, well, remember the zeros are the x-intercepts. All right, the x-intercepts. So again, the zeros are 7 over 2 and 0. And you have comma 1/2 and 0. All right. Now let's talk about increasing and decreasing. Okay, increasing and decreasing. All right, if you remember from the previous problem, all right, let's go and label our parts. Our vertex, what x value is that? That's 1, 2. All right, so that's 2. Now, what's way out here? All right, to the left, way to the left, you have negative infinity. And what's way out here to the right? Positive infinity, okay? So now let's address, all right, our heel, all right? from left to right. Remember, you have to look at a graph from left to right. All right, let me zoom out a little bit so y'all can see. All right, from left to right, okay? From the left side, follow this line to the vertex. You're going up, so that would be an increase. All right, that's an I, increase. And then from the vertex going down, right, you're going down, that's a decrease, right? Decrease. All right, so what we say is this thing is increasing from negative infinity to 2, and this thing is decreasing from 2 until negative infinity. All right. Hey, and the reason I say 2 is because, again, that's 1, right? Y'all see the 1 right here? And then that's x is 2. All right, these are x values. All right, these are all x values. Increasing and decreasing is always x values. All right, then our transformations. All right, our transformations. There's only a couple things. The first one is this negative. All right, this negative right here. That negative tells us that we reflect the x-axis, right? That's why this is upside down. It's because of the x-axis. The negative reflects the x-axis. Then minus 2 means we actually went right 2, right? And then this plus 3 means we went up 3. That's our transformation, guys. All right. That's our transformation, okay? Now, there's a couple examples, these U-tries. Man, we're going to go ahead and graph it based off this graph right here. All right. So let's get started. Starting at 0, 0. Okay, starting at 0, 0. Here's what we got. All right, we're going to address what's inside the parenthesis first. All right, what's inside the parenthesis first? Or inside the absolute value sign first. I'm sorry, absolute value sign first. So we have plus 3. Since this is plus 3, we go left 3. So from 0, 0, go 1, 2, 3. All right, we're right here. Then it says down 1. All right, so we go 1, 2, 3, and down 1. That is where our vertex is going to be. All right, that's our vertex, okay? All right, now remember A is your rise, is your slope. All right, A is your slope. So remember rise over run. All right, well, think about it. How many ways can you represent 2? All right, 2 is the same thing as 2 over 1. All right, so what that means is our rise is 2, our run is 1. So from here, I'm going to go up 2, rise 2, go to the right 1. All right, go up 2, 1, 2, rise 1. Up 2, 1, 2, rise 1. All right, up 2, rise 1. Up 2, rise 1. All right, and so on and so forth. So I'm going to end up putting an arrow at the end of that one. Now, we got to go the other way, guys. Okay, we got to go the other way as well. And you do the exact same thing. All right, except instead of going positive 1, you just go negative 1 because it's the absolute value. So remember how, again, you have the absolute value of negative 1. You also have 1. All right, or if you have the absolute value of 1, it's still 1. All right, well, since you have the negative, you also have the positive. So we're going to go rise 2 over 1. All right, it should mirror this. All right, so from this point, rise 2, rise 2, run negative 1. 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 All right. So there's our graph. All right. So bear with me. Let me put an edge on there. Whoa. Let me put an edge on there. So since it's red, I'm just going to keep it red. So we'll start here. Up. Maybe it won't let me. Let's try one more time. All right. All right, and then we need to put another one right here. And the reason I'm doing this, guys, is I can't draw, man. Holy smokes, man. Come on. There we go. All right. So there's our V. All right, there's our V. Okay, there's our V. Let me see. Can I change the color of this V? Yep, I can. Getting creative. There's our V. All right. So now that's our rise over run, and we got that again because of our A. A is our slope. Don't forget that, okay? Now intercepts. All right, intercepts. What's our intercepts? Well, these. All right, we're gonna find these using the calculator. We see this y-intercept. All right, we can see the y-intercept. All right, or we can actually just do it algebraically. All right, let's do it algebraically. All right, intercepts. All right, intercepts. All right, for the intercepts, and again, guys, I'm sorry this video is getting so long, man. I'm just trying to be really thorough with my explanation. But anyway, for the intercepts, we can see this first one. All right, this is 1, 2, 3, 4, 5. All right, so our first y-intercept, all right, is going to be 0, 5. All right, this is a y-intercept. Now for our x-intercept, guys, we're going to remember make y 0 and solve this. All right, so I'll do it right here real quick. If I make y 0, all right, you have 2 times the absolute value of x plus 3 minus 1. Add 1 to the other side, so 1 equals 2 times x plus 3. Divide by 2, so you have 1/2 equals the absolute value of x plus 3. All right, and then we got to have one positive element, or better yet, here, let's do it. You got a positive element of this same equation, and you have a negative element, 2. Now, subtract 3, so you have negative 3. All right, on this side, that cancels, right? So I'm going to convert negative 3 to have the same denominator over 2. So how about negative 6 over 2? All right, plus 1/2. All right, because negative 6 divided by 2 is negative 3. All right, and negative 6 over 2 plus 1/2 will give us 5/2, or negative 5/2, right? And over here, subtract 3. Subtract 3. All right, well, we'll convert that to, again, negative 6 over 2 minus 1/2. All right, and that'll give us a negative 7/2. All right, that's our other x-intercept. All right. So I know I said a mouthful. If you need to rewind this, rewind. Okay, rewind. All right, but I'm going to write it up here. We had x-intercept. The first one was negative 5/2, and the other one is negative 7/2. Okay. All right. Oh, I'm sorry. I wrote it like, I wrote that wrong. I should have wrote negative 5/2 comma 0 and negative 7/2 comma 0. All right, so how about that? All right, I think that's better. All right, zeros, again, the zeros are the x-intercepts. So guys, just write, just write those down here for your zeros. These are your, these are your zeros as well. All right, those are your zeros as well. Okay, don't forget that. Increasing and decreasing. Out here, again, negative infinity. Out here, positive infinity. What's in the middle? 1, 2, 3. All right, so this is negative 3. All right, so this line right here is going down to the vertex, so that would be a decrease. This line right here is going up, so that would be an increase. All right, so we have an increase from negative 3 to positive infinity. And we have a decrease from negative infinity to negative 3, okay? And then lastly, transformations, all right? This will be a left 2, all right? Left 2. I'm sorry, left 3. Left 3. Sorry about that, guys. Left 3. I was looking at that. So left 3, down 1, and vertical stretch by 2. Okay. Now, for the sake of the video, guys, it's gotten so long. I'm gonna leave this for you guys. All right. Please, please, please use this to your liking. Okay, use this to your liking. And I wish you the best. Good luck, man, on your quiz or test, whatever you have. Oh, don't forget, subscribe. All right. And if you like the video, hit like for me, okay? And good luck.